endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and growth as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of this session is MariaDB cluster for high availability, world's most advanced open source database cluster. Our guest speakers today are Sonali Minocha, Lead Database Practice, OSSCube, and Abdul Manaf. He's a database administrator at OSSCube. Sonali is India's first certified MySQL database administrator. She actively promotes use of open source in businesses all over the world and have co-founded OSSCamp, a community focused on open source knowledge sharing. One of her passions is to speak at international conferences and meetup groups on various open source technology topics. And her most recent speaking assignments have included OSSPAC, Singapore, OSI Days, India, International PHP Conference, Germany, National Open Source Conference, India. Abdul Manaf, he's a professional and highly motivated, having more than 3 years experience in MySQL DBA and development activities, as well as having rich experience in data migration and integration activities using SQL scripts and Talent Open Studio experience. We expect this webinar to last for an hour with 45 minutes of presentation and 15 minutes for Q&A. So if you have any questions, please submit them using Questions tab on your control panel. So without further delay, I introduce you all to our guest speaker. Over to you, Sonali.
Thank you so much, Deepika. A very good afternoon to everybody. So today we will be talking about MariaDB cluster for high availability, which is the most advanced and the newly technology in the high availability area for open source databases. So before I get into high availability solutions and the main agenda of the webinar, let me give you a very brief introduction about OSSCube. OSSCube is a global solution provider. We provide consultancy, development, integration, and support for all open source technologies like PHP, MySQL, MariaDB, Hadoop, and other big databases services. We develop integrated enterprise business solutions on different open source technology. We are TMM level 3 certified organization. We have a flexible delivery model where we do fixed cost projects, we do staff augmentation, and where we do time and material based assignments also. OSSCube practice focus areas are, as some of you must be aware of, PHP, which is a Zen product. Most open source portals which you see are based out of PHP. OSSCube is world's only Zen Center of Excellence certified by Zen itself. For database practices, our major focus on open source database practice like MySQL, MariaDB. We do a lot of Hadoop training, consultancy around Cloudera. We are the Asia's first Cloudera training partners. Not only we do database consultancy training and a lot of remote DBA and on-site DBA work, we also work a lot of data integration tools like Pentaho and Talent. The other technologies of open source which we work on are Sugar CRM, Exxon, Drupal, Pimcore, and Magento. These are to name few of the technologies which we work on. So OSSCube helps any organization to have an integrated business solution which is based on different open source technologies like Zen, Sugar, Magento, Drupal, Pimcore. We do custom application development for mobile apps as well as web. So now, without wasting our time, let's get to our main agenda of the webinar. So in next 45 minutes, what I and my co-speaker Abdul will be speaking on, we'll be talking about high availability, MySQL replication and its problems, how few of those problems are overcome by Galera Cluster. Then we'll be doing a small implementation and a hands-on exercise on MariaDB Galera Cluster. So let's talk about high availability, why it is important, and is it important? Yes, definitely it is important. That's why we are having this webinar and all of you are attending it. So before understanding high availability as an engineer or a DBA, as a user, how important this high availability is. Let's say we use a Facebook. Most of us use a Facebook application. At that scene, when I log into the Facebook application and it is only available to us for the 70% of the times when I log in, will you ever go to that Facebook application and use it? You are not sure when I have posted some data or some post or some photographs which I have uploaded on the Facebook. You are not sure when the next time you will log in that photograph is going to be there or not. So will you use those apps? No. Even if you lose some post or photograph, you might be okay. But let's say take an example of a banking application where you have an online banking application where your account details are there, where you do a lot of transaction online transfers. And if you lose all that data, will you work with that bank? I don't think so. So as a user community, when I'm using different portals, when I'm using different applications, high availability is very important. Reliability of the system is one of the major concerns of a user to log in and use your application. So when it is one of the basic criteria as a user I choose to use any application, definitely it becomes very important as an engineer or a DBA to develop an application which is reliable and highly available. So, but are all the applications need to be available at the same degree? That means when I say that Facebook and banking application, for both of them, data is very important. But is a data loss for both of them means the same thing? Actually not. So what level of availability you are looking for, which in technical terms we call how many nines are defined by what kind of business you are running and what kind of application you want to use. How much data you can afford to lose, and how much your users care about whether their data is lost or not. So if we talk about availability in technical terms, availability means the uptime ratio of uptime with the total sum of uptime plus downtime. So we have different nines which we want to achieve, and from an application to application point of view, these nines may differ. For example, I have a payroll application which I am using for an internal system. If it is down, let's say for 1 hour 68 minutes, which comes out to be 99% or 2 nines available, I may be fine. However, I may not be fine if I lose a bit of data of that, because that's my salary data for my employees, which I cannot afford to lose. However, downtime might be okay. So depending upon the kind of availability nines you are looking for, different topologies are there. Why do I care? Why not everybody have 9 nines, where I have only 0.6048 milliseconds of a downtime per week? Because that adds cost. Every availability 9 increases the cost of your infrastructure, your deployment, your topology needs to be designed, your application needs to be designed in such a robust manner that you achieve maximum 9 nines. So depending upon the criticality of your application and availability, you need to decide the nines of your system and then decide various topologies which can be used. But the basic principle for whatever topology you use is, if you need a high availability, you cannot have any single point of failure in your application. If you have any server which is a single point of a failure, that means you cannot have availability. Either you lose data, you will lose your users, and you will not, your application is not going to be available to your users all the time. Then is a reliable crossover. In many topologies, in very good topologies where you have got a lot of servers, the crossover at times becomes a single point of failure. Then, if both are taken care of, the second thing is servers do crash. However, the efficient your system is to find and detect the failure. That tells you how nicely you have engineered your high availability solution. So detection of failure as it occurs should be as fast as it is, the better your solution is. So you have scheduled and unscheduled downtimes. So when you have an unscheduled downtime, you have a failure of host, failure of database, operating system failures, other different failures. So if you have the single point of failures, definitely this will cause some data loss and this will impact your business. So how different people have come over this HA solution. So MySQL has got certain technologies and inbuilt solutions which provide you a high availability to certain extent. However, you can have a different topology build up around those high solutions to achieve the kind of nines you are looking for. So we know that they have MySQL Replication, MySQL Cluster, MySQL with DRBD, Oracle VM template for MySQL, MySQL with Solaris Cluster, MariaDB, Galera Cluster. These are few higher solutions which are available on the shelf of MySQL. So for this presentation, we will be talking about more of a MySQL replication, what limitations MySQL replications have, and the MariaDB Galera Cluster implementation. So let's move on to the first very basic HA solution, that is MySQL replication. This was introduced in MySQL version 3.23. It is one of the killer features which MySQL came up with because replication is a very easy to set up. It allows you to have the online replica or the data or the backup of your data which can be accessed by your various applications. So it is a very simple architecture where you have one master and you have one slave. You can scale up your slaves by adding a number of different slaves to your master. So the implementation is as simple as that. You have one master. What you have to do is when you are setting up a replication, your master needs to enable your binary log file. So what happens when I am doing any changes in the database of a master, any DML, DDL, where I insert, update, delete the data, it gets logged into the binary log file. These binary log files using the bin log down thread on the master are related to the slave, and the slave reads this binary log file and then writes it to the relay log information file which it has and then executes that binary log file. For example, I have a database where I have inserted certain row or created one table on the master. This create statement is logged in the binary log file. The slave reads this binary log file and executes on the slave database. That's how the basic replication is set up. In this setup, you have to tell slave who my master is going to be, which binary file I have to read, and from which position the slave has to read that binary log file. Though there were certain limitations in this kind of a binary log file which were there. For example, if I say, let's say, insert into some table, insert into some row where you are inserting the value as current date and time, and when it goes to the slave, there is certain lag and it executes the same statement. Your data is not correct because now the current date and time on the server has changed. So to overcome that, the MySQL came up with a row format of a binary log file in version 5.1. So these issues of non-deterministic functions were overcome to a certain extent in this kind of version. The basic problems if you see in this MySQL replication is it is a single threaded. So there is a slave lag because there is one thread on the slave with the help of which the slave reads the master log file and executes on its slave. So if a heavier transaction is executed on the master, there's a lot of data which gets executed. It gets copied to a slave using IO thread and it gets executed. So because it's a single threaded, there's a lot of lag which is happening. Not only this, the other major problem with the MySQL replication is it's an asynchronous replication. Asynchronous replication means it's a one-way replication. Master executes something, it goes to the slave. Slave may or may not execute that transaction successfully, and master has got no clue of it. So because it's an asynchronous replication, the chances of losing the data is very high. So these two major problems are there. However, when you have a master and slave replication, definitely you can have a topology which gives you a slave on which you can scale up your reads, and the slave can always be used as a hot backup machine. So the very first picture if you see on my slide is a one slave and one master. which is allowed in MySQL topology, that's no problem. However, the master is one on which the writes and reads are happening. Slave is a read-only slave here. So if my application wants to scale out and have many updates coming in, I cannot use this topology, because if I start updating the slave also, because it's asynchronous, slave does not know what's getting executed on the master, master does not know what's getting executed on the slave. So their primary key uniqueness problems might come in and their application will break. So as a result, in this application, I can only scale out to reads as of now. But this is very good in case of applications where the applications are read intensive and not write intensive. I can simply add up a slave, a new machine comes in, the existing application is running. I just add a new slave telling the slave who is your master, from which position you have to start reading, and the slave comes live and the read capacity of an application increases. One thing which we have to keep in mind is, in this multiple master topology is not possible. That means one slave cannot have multiple masters. One master can have multiple slaves, but one slave cannot have multiple masters. It's because the slave reads the binary log of a master. To a slave, I can only tell slave who is your master and from where you have to read, what is the binary log file name and what is the binary file position. I cannot give these two instructions to a same slave. So I cannot set up a master slave, multiple master and single slave configuration. However, I can have a different layer of slaves in that. I have master, then I have slave, and then slave can in turn become a master for other slaves. So that topology is possible. As I was sharing with you that these topologies are very good when I have a read-intensive application, but might not give me that advantage of upscaling my updates. So there's another thing which we have, which we call as a master-master application. Master-master application can help me first with having a high availability master available. So which I will be sharing in the further slides, how it can be used for high availability. It can also help me to scale up updates. However, when I am setting a master-master application, there are many technical things which I have to keep in mind. For example, if I have primary keys, then I have to set an offset. Because if both the servers or both the master start using an auto increment key in the fashion, because they don't know what's happening on the other slave because of asynchronous application, both the masters may create a same ID and there will be a conflict. So I have to tell the masters how do you set it. Because master 1 is a slave for master 2, I need to also tell them how to read their binary log files and what to write in their binary log files. So there are certain configuration parameters which I have to set it. This is not a default application which is supported by MySQL. I can do it by setting certain variables in MySQL. However, it is a little bit vulnerable and that's not as simple as setting up a master-slave application. Same is the case with a multi-master application. The same parameters take care of, which I have to take care in master-master application. So these are the various limitations which we know are there in MySQL, like updating slave instead of a master. If you do it by mistake, if your update goes to your slave, definitely your application will break. Non-deterministic functions I have already shared. Then the major thing which you have to always keep in mind is that there is a capacity which a single thread can monitor. Because it's a single threaded process, you have a slave lag which is happening. So, while in our consultancy, we came across many organizations where the application is set up, but the flags are lagging too high. So what happens is the transaction has already completed on the master, but when I try to read the same data from the slaves, I get a different data because the slave lag is too high in those cases. Because it's asynchronous, you will lose data, and definitely the replication master and the slave can be out of sync in case of the very large amount of data which is getting transferred to the slave. There is a lag, which definitely, if I'm even trying to scale up the read, I might not be able to see the impact of the transaction on the master on the slave instantaneously. So these few things I have to understand what kind of transactions are getting executed on master depending upon the size which needs to be transferred, how much lag my application can afford. If my application can afford a lag of 1 or 2 minutes and my application, the kind of transaction I am getting executed, gets executed on the slave within this lag, it is very good to go. So you need to understand your application first, what amount of lag is acceptable. What if asynchronous, because of asynchronous replication you lose some data, can your application afford to lose it? If yes, replication, you can go ahead with MySQL replication. MySQL master slave failover. So in this we see that there are two MySQL master. One is MySQL master, one is MySQL slave. The client is directing all reads and writes to MySQL master and reads to slave. So what happens is when the master goes down, the application is broken, then you have to redirect your writes to MySQL server slave. So when you redirect these writes to slave, definitely there is going to be certain downtime because this does not happen automatically. You can write scripts which can be semi-automatically done. However, it's a manual process. Automatic failover is not there in MySQL replication. This is multi-master scale where we see there are two masters. However, we are using only one master for read and write. For the other, we are only using it as a passive MySQL master. We are not doing any updates on the MySQL master passive, which is the second you see in my diagram. So if the first one goes down, the reads and writes are directed and transferred to the active, to the MySQL master passive, which becomes the active master now. However, still I would like to reiterate that it's again a manual process or a semi-automatic process. The failover does not happen automatically. So the other issues, if we see that one major is that we don't find an automatic failover services. The queries become different on master and sales because they are asynchronous. I might route some relay log files and the bind log files are corrupted, then the replication cannot happen because I read from binary logs, I write it to relay log files. If something goes down, then definitely the replication is broken. So I have to be very careful when I am doing all these kinds of replication setups where the automatic failover, when I am considering this as a high availability solution, definitely I have to create a topology where the master and the slave does not become the bottleneck for the availability of an application. So now let's talk, that was something which we covered in MySQL replication. Then let's talk about a new technology which is MariaDB Galera Cluster. So if you see the features, the broad features of a MariaDB Galera cluster is it's a synchronous replication. So that means if a transaction has happened on one node, it goes to all the nodes. It's not possible like in MySQL replication that if the master has executed a transaction and the slave has not successfully executed, still it is present on the master and it is not there on the slave. If something is happening in a Galera cluster, it's a synchronous replication. If master executes it, all slaves execute it. If any of the slave or any of the node is not able to execute it, the entire transaction is rolled back. So that's why it is synchronous. Consistency of a data is very high in case of this cluster. You have active multi-master topology, read and write to any cluster node. So when we were doing MySQL replication, we saw this was a limitation that only the reads can scale up because ideally all my slaves should be read intensive. Should be read intensive. However, when I'm talking about these kind of nodes, the read and write can both be scaled out because all my nodes are multi-master. I can write to any of the nodes and it will be replicated to different nodes across. Then you have automatic membership control. Fail nodes drop from the cluster automatically. And the same way, when I add any node, the node automatically joins it. So whenever I have multiple nodes, from a standpoint of view of high availability, even if the one node goes down, I have got other nodes who are fully capable of entertaining all the reads and writes from an application. So the automatic node, when they join it, I don't have to do much, I just have to join it and it will automatically sync with the entire cluster and will take up from there. It's a true parallel replication. You can have direct line connections to MySQL. It looks like it's a MySQL because when I'll go into detail, you will understand it's a MySQL layer. Using the API, there's a plugin which is used for Galera Cluster. You can use it with any DBMS. Right now, it is only used for MySQL. It is available only on Linux as of now. No slave labs happen because it's a synchronous replication. When anything happens on the one node, it gets propagated to all the nodes. A transaction is only completed when it has gone to all the nodes. So no chances of having any slave labs. So whatever problem I had, that if there is a large amount of a slave lab, master executed something, slave does not know about it, the slave gives you stale data, that problem does not exist in Galera Cluster anymore. There are no transaction nodes. Both read and write are scalable, and you have a smaller client latency. So this is basically a Galera cluster which provides a virtual synchronous replication. In my earlier slide, I said it's a synchronous replication. Now I'm saying it's a virtual synchronous replication. So let's understand what's the difference between synchronous replication and a virtually synchronous replication. See, MySQL cluster is a synchronous application. So if you talk about MySQL cluster, what happens there is that there is a two-phase commit. The transaction goes to all the nodes. When all the nodes say that's the first phase, and when they successfully tell them, okay, the transaction is good to be executed on all the slaves, then the second phase commit happens, and then the commit is propagated to all the nodes. And the synchronous replication has a two-phase protocol. But this Galera cluster does not follow two-phase protocol. It just have a mechanism which is called as the certification-based replication. So let's see how the commits happen in this kind of a cluster. That will take you to the next slide. It works best with a transactional database, InnoDB. Because you'll get the reason when I talk about the next slide why it works best with InnoDB, because it's a transactional storage engine. There is no slave block. You can have master. So this was I was talking about, that Galera cluster implements virtual synchronous replication using certification-based replication. Certification-based replication uses two major things. One is a group communication, and then the other is a transactional ordering technique, or a global transaction ID is generated. So what happens in this is that you have a client which sends an update to a server. When the client server says it is okay to commit, it goes back to the client and it commits it. The commit has already happened on the server first node. Then that node writes the entire data which has changed along with the primary key into a write set. That write set using a global communication and at the global transaction ID is broadcasted to all other nodes. All other nodes check this transaction ID with whatever transaction ID they already exist. They check for the primary keys which are generated. If everything is validated on that node, the certification test is passed. They say okay. When all the nodes says okay, it goes to the originating node and it says okay, and it commits the transaction. So the transaction gets completed. However, if any of the certifications fails on any of the nodes, the entire process is rolled back on the initiating server also. So the transaction which was committed, it gets rolled back. That's why I said it works best with InnoDB because it's a transactional storage engine. However, if you talk about MySQL, it's non-transactional. However, there are certain patches available. If you download those patches on a MySQL, then the certification-based application can work there also. So if we come back to our previous slide, it says the certification-based application uses group communication and transaction ordering techniques. What is required for certification-based application are three things. Without these things, it is not possible. Transactional database, that means a transactional storage engine in case of a MySQL, which is InnoDB. You can also have MySQL with certain patches. It has to be atomic changes. So even if any change happens on a database, the entire transaction of which gets rolled back, the data should be able to maintain its integrity and roll back to a stage where the entire data is consistent. Then you have the global ordering or the sequencing of the transactional ordering of the transactions. So each transaction which you have needs to have a unique global ID which is generated across different nodes. Whomsoever gets the write record generates that unique transactional global ID, and when the write set goes to the other node, it carries that transactional IDs with it. So that's how the Galera cluster implements virtually synchronous application. Because it's not two-phase commit, that's why we say it's a virtually synchronous replication. The internals of a Galera cluster looks like this. So you have one DBMS. As of now, it is only MySQL, but it can be any other DBMS which can use the WSREF hooks and APIs which are provided by MySQL Galera cluster, and they can use group communication protocols to send out this certification-based application. So now one thing which is very important to keep in mind whenever you have an application in place. Once your application starts in MySQL, when you add a new slave, you need to take the backup of that slave and then set both the master and the slave in sync. So that, and you tell your slave and master, okay, now you are in sync. Now you can start replicating. Any new transaction comes on the master through binary log gets replicated to slave. In this, the state transfers happen on its own. There are two types of provisioning which can happen. One is the state snapshot transfer, where the snapshot of the entire node transfers to the other node. And the other is an incremental, where only the differential data which is not present on the node gets replicated. In case of a snapshot, definitely it is going to take a larger time because the entire data gets transferred. If it's logical, definitely it will take a longer time. If it's physical, then the problem is, then you might be able to get the faster output as compared to logical, but definitely the configuration of both the machines have to be same from where you are using these techniques for the transferring. Then we have what is called as an incremental state transfer. The incremental state transfer happens instead of transferring the entire data from one node to the other, only the differential gets transferred. However, there is certain condition which needs to be followed. The joiner ID or the new node who is getting the data need to have a same UUID as that of the group. And the one donor who is giving to give that differential data must have that data in its right set cache. So defining the right size of the right set cache is very important. Too large if you have, it will have the entire snapshot of the data, so the incremental state transfer will become more like a complete state transfer rather than the incremental one. So this is how the Galera cluster more or less looks like. You have MySQL replication API is there, which has the hook. This API talks to Galera group communication library. Then you have the snapshot transfer, which can happen through MySQL dump, HRDB. Then you have InnoDB and MySQL storage engines, which are very particularly used in MySQL databases. So that was the basic internals and the architecture of a MySQL cluster. Before wasting any time, I will hand over this session to Abdul, who is going to share with you how this cluster can be implemented in just 5 minutes, and he will be sharing you the quick tips and tricks to set up this cluster. Over to you, Abdul.
Thank you, Sonali. Hello, everyone. I will be explaining how to configure and implement MariaDB Galera cluster. So basic setup of MariaDB Galera cluster requires minimum of 3 nodes, because if one of the nodes fails, at least remaining 2 of the nodes will have majority. In our demo, we will be using 3 Linux Ubuntu machines that we have an internal infrastructure. In order to configure the setup, we will be following some steps. In the first step, that is remove old MySQL. This is not necessary. If we have already installed MySQL and we know the configuration and everything, then we can even install Galera cluster over the existing installed MySQL. If we are new to it, then what we can do, we can remove the existing MySQL setup and then install the new server. In the second step, what we will be doing, we will be adding MariaDB repositories to our Ubuntu machines, Ubuntu sources.list. In the third step, what we will be doing, we will be installing MariaDB and Galera patches. So when we say add the MariaDB repositories in the step 2, what we do, because direct sources.list direct are not available with the apt-get. So what we have to do is we have to receive the keys from Ubuntu server, and then we have to add the MariaDB repositories in the sources.list. Then we have to get the update for Ubuntu, and then we have to install the patches for Galera and the MariaDB server. So in the fourth step, that is the most important and configuration step. In this step, we will be configuring the nodes to run as a cluster. If we see, there are some settings, MySQL settings, that is bin log format row, default storage engine, InnoDB. As you already explained that MariaDB Galera cluster uses default InnoDB engine. We can have also support for MySQL, but that is some experimental support or passive support. I have also set InnoDB auto increment loss mode 2, because this is used for setting the auto incrementation. Because if we have 3 nodes, there will be a difference in auto increment keys. Some server will generate 2 and some will generate odd and even numbers. So just to get complete increment, we use the InnoDB auto loss mode 2. Query cache we have to disable, and bind address we have to set as it can connect from anywhere. Now we have to add some Galera settings. The right set replication provider is already added to our Ubuntu system when we install the Galera pledges. And then we have to name the Galera cluster. You can name it whatever you need. Then we have to add the IPs of the machines on which we are going to add the cluster. So here I have just explained 3 nodes. So I have added 3 nodes, whatever are those, 10.184, then another one is 10.185, then 10.186. So on every node, you have to repeat the step 1 to step 4. Then all the nodes will be ready to connect. In the next slide, what we have to do is, at step 4, every node is running MariaDB individually. Now we have to configure the node to run as a cluster. So what we have to do is stop MySQL on every node. Then on the node 1, whatever you can say is the node 1, you can have to start MySQL with the --rest new cluster. So once this is started, your cluster is going to be started. If you will go to the login MySQL and check the rest cluster size, it will show the size as 1. Once we will start the node on once we will start the MySQL on other nodes. If you start the node 2 MySQL, then it will show the cluster size as 2. Once you will start the cluster 3 MySQL server 3, the cluster size will be shown as 3. Now we will be going to technical implementation on my machine that I have in local infrastructure. So here I have already connected to my nodes which are in local infrastructure. So if you can see, I have node 1, node 2, and node 3 that I have already connected from my machine using putty. So we will be moving through some steps that I have explained. First, we have to remove the MySQL. It is not required if you are using fresh machine, then it is not required. Let's say we are removing it, will say that it does not exist, so need not to be removed. So this is not required. First step is not required because I am using fresh machine or I have already deleted the data. Now I have to add MariaDB repositories. Next command, I am installing Python software properties. I am doing this because this will add the command which are used to configure the sources.list. So this is also already installed. We have to repeat the every step on every node. So on the node 2, I will doing the same. Also on the node 3, I have to execute the same step. So everything is fine. Now I have to receive the key from Ubuntu server. So on the node 1, I will be adding the key. So if you see the total number of processes is 1, unchanged 1, because I had already downloaded the keys, so it shows unchanged 1. If you are doing it first time, it will be show as it is installed or received. And on node 2, you have to do the same. So on the every node, you have to repeat the step. So on the all 3 nodes, we have received the key. Now I will be adding the repositories to my sources.list. On the node 1, I'm adding the repository. So it is added. On the node 2, I'm also adding the repository. So this is done. On the node 3, I will be adding the repository. So this is added. Now I will get the update from server. On the every node, so it is getting updated. On the node 2, I will get the update. This is also getting update. On the node 1, same step we have to follow. So these nodes are getting update. You say almost they are getting the update. It does not take much time. In quick time, it will complete. After that, we will be installing the rsync, because the basic protocol for transferring state transfer, we will be using rsync. Either you can use MySQL dump or Percona extra DB. So that we can also use, but for the first time I will be using rsync. So let's install the rsync. By default in the Ubuntu machines or Linux machines, rsync is installed, but let's check it. It is already installed. On the node 2, it is also installed here, but just check it. It will not install it if it is installed already. So everything is done. Now I have to add the Galera patch. Using apt-get install Galera. From the node 1, I will start apt-get install Galera. So this is adding the Galera patches. On the node 1, meanwhile, I will be adding the Galera patch to other nodes. Node 3, let's add on node 3. So on the node 1, I am, the Galera patch is installed. Now I will be installing MariaDB Galera server. So it will prompt for password. When you say yes, it will prompt for password. Let's set the basic password, whatever you want. Repeat it. On the node 1, on node 2, repeat the same step. Yes. It will prompt for password. Set the basic password, whatever you want. On the node 3, do the same. So let's move the node 1. If you see, the server is getting started. So now the server is installed on the machine. Independent MariaDB is running on every machine. Here it is installing, here it is installing. On the node 1, it is done. If you check that MySQL is running here, just log in. Yeah, it is installed. If you can see, it is installed on node 1. Now we have to configure it as a cluster. Every node we have to combine in a cluster. So for that, we will be adding some configuration files into our conf.d directory. If we see the my.cnf file, pi, etc, MySQL and.cnf, it is the configuration file for MySQL. Then you will see here it will include the conf.d directory. So whatever you will, if you see in the last, it includes the conf.d directory. So we will be adding our configuration file for cluster in the conf.d directory. So let's create a file in the conf.d directory for configuring the server as cluster. Let's name it galera.cns. I will copy my configuration from my document. I have already created that. So here I have done it on node 1. I will repeat the same on node 2 and node 3. I copied it on node 2 as well. On node 3, on the same location, copy the configuration. whatever the name you want, you can give as CNF. Now every node has the configuration. Now what we need to do is stop MySQL on every instance. We will start it as a cluster now. I'm stopping it on every machine, every node. The node 3 I have executed, on the node 2 I am executing it. Execute the same on node 1. So if you see, it is stopped on the node 2, node 3, and as well as on node 1. So taking node 1 as my first node, I will start the cluster with the rest cluster. If you see here, I have written that I will be starting it as with rest new cluster. So let's start the first node with this. So it is starting as a cluster. So it is started. Let's go to the MySQL. Check that it is started or not. So how can we check the status? What we can do, show variables, show status like rest. Yeah, here it is. So if we see the cluster size, the important variable is rest cluster size. If you see, the cluster size is 1 because we have only started the node 1. When we will start the node 2 and 3 as well, so it will increase. Let's start MySQL on the node 2 as well. Start. So once it is starting, we will check the status with the cluster. It is still 1, it is starting from here. So once it will be started, the cluster size will be 2. Yeah, if you see, now the cluster size is moved to 2. When I will start my cluster node 3, the cluster size will move to 3. I'm starting MySQL on node 3. Let's check the status on node 1. Yeah, if you see here, the cluster size is moved to cluster size 3. So this is the basic configuration. I have configured MySQL or MariaDB with the Galera cluster with a 3-node implementation. Let's test our cluster. We can create a database. So we have created database on node 1. Let's check it on node 2. So if you see here, the database is created. Test cluster. Let's use this and insert on node 2 something. Create something on node 2. So let me create table. Create table test cluster new. I will create ID and now let's create a simple column, but we should actually primary key. I'm just checking, so I'm doing like this. I will check the same on node 3 that table is created or not. So we use the database where I created the table inside test cluster, show tables. So if you see the test cluster new is created on the node 3 as well. So I have written on node 1 as well, on node 2 as well. So we see that it is also scaling the writes as well as the reads. So this is the basic configuration of our MySQL or MariaDB Galera cluster. So that's all on my side. Now I will be moving to question answer. Before that, I will thank to everyone for their for coming to webinar. If there is any query or suggestion or feedback, you can provide us on our social channels. So from now, I will be moving to question answer.
Thank you, Abdul. Thanks, Sonali. Thanks for this insightful presentation. I would request you to take up the questions now.
Sure.
Yeah, the question from Ravi Kapadia is that this is working on Linux only. Yes, it works on the Linux only. It does not, the rest provider has not support for Windows till now. It only supports Linux till now. So yes, it is Linux only. There is a question from Rishikesh Road. How you are going to monitor cluster and how the client's failover happens. So for monitoring, there also come some paid tools like cluster control or something like that. But you want to monitor by yourself. There are some variables like I have shown using rest underscore variables. There are some variables. By using those variables, by writing your script, you can monitor those variables and check the cluster status, the cluster health, the usage of various things. So you can do it by your script as well. And so to write data is from Nirav Gandhi. He has already left because question is also not very clear. So there are not many questions. So that's it. Thank you everyone for coming to webinar. You can join us on our TechGeek page as well for upcoming webinar. And if you have any feedback or something.
Sure. Thank you, Abdul. There are a few more questions. I would request you to take them up, please.
Yeah, sure.
Thank you.
There's a question from Vimal Kumar Prajapati. Does tables in MySQL require primary key in the application like MySQL Server Transactional Application? Vimal, it is not necessary. In MySQL native application, it is not mandatory that there should be primary key. But in the MariaDB Galera Cluster, it is mandatory because you will not be able to maintain the integrity of the data. So it is required to have primary key. But for the replication, in my opinion, you should also have the primary key. But it is not mandatory for the MySQL native application. But for the cluster application, it is mandatory to have primary key. Otherwise, your deletes maybe have issues because you will not be able to find which rows I am going to delete. Let's say it uses the certification-based application. The certification is performed on the basis of the primary keys because those are compared and whatever the things are there, that has to be depend upon the primary keys. So for the cluster, we need the primary keys. From Aditya Rathore, where the database files will be stored. Like every MySQL setup, there is a data directory where live MySQL. So the files related to MariaDB or MySQL will be stored inside where live MySQL. That is the by default definition. If you want to change the data directory, you can change it easily by defining it in my.cnf or the configuration file. Can we store image data type from Deepak Garg? Can we store image data type in the MySQL? Yes, there is a binary log object that where you can store the images. Rajiv Rumale has question, can we follow the same steps for installing it on AWS server? Yeah, we can install. In case of SST during system transfer, does it apply any logs on table? From Vimal Kumar Prajapati. When SST is performed, it does not perform any log. But when IST or some transaction is going on, it performs the log. Because in the SST, you are first time or when you install the setup or set up the cluster, the complete data is transferred from one node to another node. But when you use it using MySQL dump, it logs the table when you take the dump. In the extra backup, it does not require the logs. When you use the RC, it does not require the log. So that's it. There are some repeated questions. That is all. There are some questions. You can, if you can follow our page, we can answer there as well. So you can provide your feedback. And
so if you have any questions or you come across any clarifications regarding this topic, you can tweet us, you can send it to our Facebook page or any social channels. You can also send it to TechGeek page. That will be a forum, I think, which Deepika will be creating, where you can post your questions, and we'll be more than happy to reply your questions there.
Yeah, thank you, Sonali.
Our pleasure. Thank you, everybody, for taking out time from a busy schedule and attending this webinar. Hope you got something new information which can be used in your day-to-day life from this webinar. Thank you, everyone.
Thank you, Sonali, so much. Thank you, Abdul. Thanks for this insightful presentation. I'm really thankful to you for conducting this webinar today. I'm also thankful to all our participants for their support in making this webinar a huge success. So for those of you whose questions have not been answered, you can go to techgeek.com for in Expert Speak section. In the same webinar page, you would be able to see a forum where you can post your questions, and our speakers will be able to answer your questions on the same forum. Thanks a lot for your time today. Thanks for joining us.